Okay guys, so over the next 2 days, we're going to go ahead and review two topics. Today we're going to go ahead and do a little review of graphing trig functions. Remember, this includes all of our original trig functions, sine, cosine, tangent, as well as our reciprocal functions, secant, cosecant, and cotangent. Okay. And then tomorrow we'll go ahead and we'll review a little bit of our inverse trig functions and compositions. So I'm just going to go over one example each from your guys' end of unit review. So this could be found in the back of your packet. I'm going to do numbers 41 and 45, we'll say. And then we're going to go ahead and have you complete the rest for me as practice there. So to start off, let's take a look at number 41. We have negative sine of 4x. All right? We're just trying to figure out the amplitude period and graph this guy. So first off, for amplitude, that should be pretty easy. It's just whatever number is out in front. In this case, that number is -1, but we're always going to take the absolute value, guys. So our amplitude is actually going to be +1. And then remember, our period we can find by doing 2 pi divided by the absolute value of our b value, which in this case is 4. So that's just going to be pi over 2. So just to clarify what these two things mean. Amplitude tells us how far above and below we're going to be from our midline. And the period tells us how long it takes us to complete a whole cycle of sine, which, remember, looks like this. But we do have to take into account that negative out in front. So this guy is actually going to be flipped. So instead of like that, we'll have something like that. So remember, use your calculator when you are going ahead to graph these guys. So I'm going to go ahead and use my graphing calculator here. My window is already set up. Hey, if yours isn't, go ahead and make sure your window is going to give you something that looks really similar to your graph here. Okay, and I got y equals negative sine of 4x. I can go ahead and graph that guy. Okay, and it looks like something weird. So my first guess would be my mode is not correct. And it looks like that was the problem. My mode is in degrees. So go ahead and make sure you're in radian. And there we got something that makes a little more sense for us here. Okay, so what we're able to see here is that we start at our origin, and after pi over 2 units, we get back and we complete a cycle. So I'm going to do something like that. And remember, we decided that this guy, because it had that negative out in front, instead of starting and going up, it went down first. So it would look something like this right here. And then we're going to repeat that every pi over 2. So our graph should look something like that. And there we go. So now let's jump over to something that's a little more complex, where we have some shifts and translations that we're dealing with. So for number 45, we have 1/2 cotangent of x minus pi plus 3. First, let's go ahead and get all our characteristics. Remember, any reciprocal function is going to have an undefined amplitude. Any reciprocal function, and also just tangent function as well, will be undefined when it comes to amplitude. And to figure out our period, with tangent and cotangent, we just do pi over our b value. It looks like this guy is just 1. So that's an absolute value there, if you weren't sure. And our period is pi. So remember, that's going to be how long it takes for us to complete a cycle. Our phase shift is our left or right. So in this case, it looks like we shifted right pi units. So we're going to say right pi. Vertical shift, up or down. Looks like we're going up 3. That was because of the +3 right there. And then remember, our midline is always going to be the same as whatever our vertical shift is. So I'm going to go ahead and draw that midline to start off. And then to get all of my asymptotes, which, remember, every reciprocal function has asymptotes in it, I'm going to go ahead and actually graph this guy. Be careful when you're graphing it. We got a lot to do, so check it out. First, I'm going to do 1/2, and then to write cotangent in a calculator, you're going to actually have to do 1 divided by tangent. Okay? And then we can do our remainder here, which is going to be x minus pi And I'm going to close the parentheses, and then I'm going to do, looks like I got one more parenthesis I got to put in there, and then plus 3. Right? So let's go ahead and check out and see what this graph looks like. There we go, we got something that looks like this right here. So our asymptotes, I'm going to go ahead and put them, it looks like at 0, and then at pi, at 2 pi, negative pi, negative 2 pi. Right? And then I'm going to hit that midline smack dab in the middle of each of those asymptotes. And remember this number out in front, the 1/2, that's not our amplitude, but it does tell us how steeply we're going to be drawing our curve here. So right here, we're going to just go 1/2 below our midline. Over here, we're going to go 1/2 above, and that'll tell us how that guy's going to look. So it should look something like that right there. The rest I'm just going to kind of do by eye, something like that. And there you go. Okay, so that was the graph of 1/2 cotangent of x minus pi plus 3. So what I'd like you to complete to practice and prep up for a little quiz on Friday is 42, 43, 44, and also 46 on the next page there. Okay, remember, my office hours are from 11 a.m. to 1 p.m. every day. So if you need me, hit me up via Google Hangout or send me an email. Hope you guys have a good day.